I'm going to go through the 1997 question 3. So this is a short, sharp one. There's only 4 parts. When they give you one and they don't give you a diagram, can I suggest very strongly that you draw a diagram, even though you don't need it for the first part or the second part? It just helps. So I've drawn myself a set of axes, and I know that A is a point 0, 1. So 0 across, 1 up. So there's the point A. And B is a point 2, 3. So I go across 2 and up 3. 1, 2, and about there. You don't have to be hugely accurate. And B is a point 2, 3. A is a point 0, 1. And I'm going to draw a line through those. This might take me a while because it's often hard. Right, there we go. There's my line. Beautiful. Now, we need to find the midpoint. Find the midpoint of AB. So somewhere here. And the reason why drawing a diagram is so much better is because you now know, you have an idea about where it should be. So the midpoint. So number 1, midpoint of AB. Well, all we do, add the x values. So 0 plus 2 over 2. 0 plus 2 over 2. And add the y values. 1 plus 3 over 2. No, my time. And therefore I get 2 over 2 and 4 over 2. 2 over 2 is 1, 4 over 2 is 2. And that looks right, doesn't it? It looks right, the point 1, 2. Okay, find the slope of the line AB. Well, having a diagram here, this looks pretty steep, and it's a positive one, so that helps me. So number 2, the gradient of AB, subtract the y values. Now I'm going to do what I should have done first. I'm going to write them above each other. So I'm going to go 2, 3, 0, 1. And that's B, and that's A. Subtract the y values, 3 minus 1, and subtract the x values, 2 minus 0. 3 minus 1 is 2, 2 minus 0 is 2, and 2 over 2 means we've got a gradient of 1. Now, we know that's 45, or we should know that that's 45. Righto. The perpendicular bisector of AB. The perpendicular bisector. Well, we've got a point that the bisector's on. So no, this is number 3. We have the point, we have the midpoint, 1, 2. So we've got that. If only we knew the gradient, but we do. Perpendicular to AB is a negative reciprocal. Negative, change the sign, reciprocal. So, M of perpendicular to AB is 1 upside down, just 1, change the sign, negative 1. Now I can use my formula, y minus y1 equals m outside of x minus x1. So, y minus the y value, 2, negative 1, x minus the x value, 1. Y minus 2 equals negative x plus 1. Going to take all of this over to the left-hand side. So I get x plus y minus 3, because I'm going to minus that 1, equals 0. Now, the last bit. The point, well, I'm going to draw this on. The point P lies on the line 2x minus 9 and is equidistant from A and B. The point P lies on the line y equals 2 and is equidistant from A and B. Now, you don't have to do this. You don't have to do this, but I'm going to do it anyway. So this is not going to be part of anything you have to do. Righto. So let's get this line through. That's not going to be good enough. So we'll try again. I really want something like that. Can I move it? No. So I'm trying to get this through here. Oh, that's much better. Just to give me an idea. So that's a perpendicular divider. Now, what do we know? If P, so P lies on the line y equals 2x minus 9. I'm quickly going to draw that. 2x minus 9, that's going to come way down here. Way, even probably even further. Way down here. And it's got a gradient of 2. So I'm going to go here and I'm going to draw a line through there. There, that'll do. Now, this point P must lie on that line, but also be the same distance. Now, for it to be the same distance from A and B, it must lie on that other equation, which we've just got. So we haven't done this yet, so don't stress about it. So here's number 4, and we're not going to do it. If P is equidistant from A and B, it must lie on the line x plus y minus 3 equals 0. But it also lies on the line y equals 2x minus 9. Now this is what we're going to be doing next in our next unit. So don't worry too much. I'm going to call that equation number 1. I'm going to call that equation number 2. And I'm going to sub this in for y. So I'm going to sub 2 into 1. And I'll get x plus, put it in parentheses, and I'll write it in a different colour so you know what I'm subbing in. 2x minus 9. I subbed all that in for the y. Minus 3 equals 0. So it gives me x plus 2x minus 9 minus 3 equals 0. So therefore I get 3x minus 12 equals 0. 3x equals 12. X equals 4. Sub that into equation number 2, which is y equals 2x minus 9. Y equals 2 times 4 minus 9 is negative 1. So I get the point 4, negative 1. And I look at my diagram. Does that look like 4, negative 1? Well, my diagram's not 100%, but yeah, it's pretty close. Now, don't worry, you are not meant to do part 4 as part of this unit. You are not meant to do part 2. You should have been able to do parts 1, 2, and 3, but not part 4. But if you have, and you've had a go at it, and you feel pretty good about it, fantastic, well done. All right.